Hi, my math people. Let's get into lesson 2 of chapter 8, perimeters of composite figures. Well, what are composite figures? You might be asking yourself right away. So a composite figure is made up of triangles, squares, rectangles, semicircles, and other two-dimensional figures. So basically a composite figure is a shape that has a bunch of other shapes that you already know put together. So an example here, we have a triangle and a square put together to make this composite figure. To the right, we have a semicircle and a rectangle together to make this composite figure. So we're going to focus on finding the perimeter of composite figures. Remember, perimeter is the outer edge. It's almost like putting up a fence around your yard. Perimeter is the outside. Just lining it up. Like if I were to put a fence around this shape, I just want to go around the outside. I wouldn't want any inside. That's area. So to find the perimeter of a composite figure, we're going to find the total distance around the figure. So let's get into this. First thing I want to talk about is if we were to use some grid paper. Now, if we were in class, this would be a lot more hands-on. I'm just going to show you what these grids are, what they mean, and we will be doing some problems like this on Big Ideas, and also you'll have some on your quizzes and tests this chapter. Fairly easy to understand, but there is something really important about diagonals here that you're going to need to know and remember. So we're going to estimate the perimeter of this arrow. So again, it's like you're putting up a fence around this entire image. You want to count up the blocks, right? Each grid on this grid here, if we're going horizontal or vertical, right? If I'm going horizontal, this would count as 1. But if I'm going vertical, this would also count as 1. So we're going to count up how many there are horizontal and vertically. But then when we're looking at diagonals, like I see one diagonal here, 2, 3, 4, 5, 6, 7, 8 diagonals. But that's not just 8 units. When we're looking at diagonals, diagonal length is 1.5 units for each of them. So if I have 8 diagonal units, right, that's 8 that are all 1.5 long. So I would have to do 8 times 1.5 to figure out the perimeter of just that diagonal units. So 8 times 1.5, when I do that, I get 12. But then I also still need to add in those horizontal and vertical ones that I started to count. So let's count those. I'll do them in blue. I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there are 20 that are horizontal or vertical, and they're all just 1 unit long. So that equals 20. But I need the total perimeter. So I'm going to add these together. So the perimeter of this arrow would be 32 units. So the most important thing here is that diagonals are worth 1.5. Count up how many diagonals are there, and then multiply it by 1.5 to get your total for your diagonals, like I did in that first step there. Sorry, I was trying to highlight that for you. All right, next, let's keep moving here. Let's do some examples more with composite figures. If it's not on the grid and it's just in front of you, how we would find those perimeters. So let's look at this shape. I see a semicircle and I see a triangle. Remember, we are just trying to find the perimeter here, so the outside. So maybe first you want to start your problems by, like, if you have this printed out, maybe you're going to highlight around so that you're looking at just the outer edges. Okay, anything inside, right? If this is your yard, you want to put a fence around the outer edges. You don't want to put a fence through the middle of your yard, so I would not count that 10 feet. That's just extra information, or it's going to help us with finding something else. So again, I'm going to take a highlighter real quick. So I have 8 feet here for my fence. I have 6 feet here, and then I have no idea how much fence I need for this curved piece. But I do know so far my perimeter is going to be my 8 plus my 6 plus whatever the curved amount is of that semicircle. Now remember, to find that curve, to find the outside distance of a circle, we call that our circumference. But since it's only a semicircle, we have to divide that circumference in half. So let's find our circumference. This 10 is giving us our diameter. It goes all the way across and through from one edge of a circle to another. So we know our diameter. So I'm going to use my circumference formula that has diameter. So that's pi times d. And we're going to divide that by 2. So let's use 3.14 times 10. So multiply those together. I get 31.4. Divide that by 2, because it's only half of a circle, and I get 15.7. So that means this curved piece right here is 15.7 feet long. I would need 15.7 feet of fence. So again, I have my 8, my 6. Now I'm going to add 15.7 in. Go ahead, pick up that calculator. Add these all together for me. When you add these all together, you get 29.7 feet. That's your total perimeter of this shape. So if there's any missing information, you should be able to calculate it and figure it out. Especially from those formulas we were given in the first lesson. We're going to use those more often and continue to use those as we move on. All right. Let's move over to the right here. I see this track. So it says find the perimeter of the running track. Remember, perimeter, it's just the outer edges. It's like we're going to fence in this track. So I'm going to take my highlighter. I'm going to highlight. All of this is getting, per se, fenced in, or we're finding the distance around it. So I do notice there's a rectangle in the middle here. Everybody see that with me? I see that rectangle. Let me actually change that to a pen so it's not so thick. And then I see a semicircle here and a semicircle here. So I have two semicircles which would form a full circle if I were to kind of take away this rectangle and kind of smush those two semicircles together, would form a full circle. Well, I need to figure out what would that full circle's distance or perimeter around it be. So again, that's finding the circumference. Now, they tell us this center point here, right? That's the center of the circle. They go from there to the outer edge, that 32 meters. That's our radius. Maybe I shouldn't use green. That's our radius. So when we're finding circumference, I want to use the equation that has radius in it. So I'm going to do my circumference equals pi times twice the radius. Let's plug in what we know. 3.14 for pi, 2 times 32. We're going to multiply all three of those numbers together in our calculator. Do 2 at a time, or just multiply all three together if your calculator does that. You should get 200.96 meters. So now we have accounted for the outer edges. We've accounted for those curved circles. Okay, I'm not going to divide it by 2 because I don't have half of a circle. I really have a full circle. Part here. Together, those two ends are 209 or 200.96 meters. Now I still have these two, which I'm going to highlight in green, edges here that I need to fence in. I know that that's 100 meters. So if this edge is 100 meters, so I need 100 meters of fence over here. That'll also tell me I need 100 meters over here. So my perimeter, I'm going to add together that 100 plus that 100 plus our curved circle sides. Add these all together. Our perimeter here for this track is 496 meters. That's our total. Hopefully you're pausing the video, taking notes as you need to, writing this all down. I feel like the more you write it as you listen, or maybe you're going to go back and rewatch it and write it as you listen to me again, the more you write the math, the more it kind of clicks instead of just listening to me and watching me. I really would like you guys writing this, filling in the notes if you can print them out, or just even writing it on scrap paper, whatever it is that you can do to get it written. I feel like that helps make the connection more to the brain and remember it.